All right, so today we are going to be going over AI used in SOAR platforms, and specifically it's going to be ChatGPT using Cortex XOR. And so we're going to go through a couple pain points in the industry, especially in like security departments and security operations. Then we're going to go into a demonstration, and we're going to actually go through a workflow inside of XOR that's being powered by ChatGPT. So we'll go through the nuances and exactly what it's doing and some of the situations it shows. All right. So I mean, that's a pretty handsome feller up there, but I'm not sure who that is, but it's actually created by ChatGPT. But so again, my name is Kevin Sistrunk. I have about 15 years in cybersecurity experience. 10 years of that is strictly in security automation, and probably about 5-6 years of that is specifically in Demisto or XOR. I have worked with a lot of different security tools, going from CrowdStrike, Carbon Black, Splunk, XIM, across the gamut across my career. I have created complete pipelines, start to finish, using security automation from the start, from like SIM to SOAR, EDR to SOAR, etc. All right. So this is actually a slide I just kind of threw in there. I was actually talking to one of the Palo Alto customer success engineers that's assigned to my company, and they said, I can't not put this in there. So the story behind this is I have a little, I'm like kind of like a hobbyist for raising chickens, and so I kind of adopted that whole defense in depth inside my chicken coop. So if you actually look, I'm not sure if anyone's familiar with like the Wise cameras, but they have like AI kind of built into it. So it can tell the difference between like a person or a package or a pet, which is anything that has 4 legs. So to make a long story short, I kind of adopted that defense in depth in there. Camera is kind of like an EDR. I have wire mesh around my chicken coop, which is like a perimeter defense, and the actual chicken wire would be like a DMZ. So I'm not sure what the automatic water connects to, but it's in there, and I'm actually using it. All right, so for the agenda, so like I said, we're going to go through some real-world pain points when you're talking about using AI, especially in security operations, and then we're going to go into how XOR and ChatGPT actually communicate with each other. It's going to be a demo, and then also we're going to do a deep dive inside of the AI reasoning, how ChatGPT takes different data from XOR and actually decides to progress through the playbook. So technically, if the way the demo playbook is created is ChatGPT is actually driving the response inside of the playbook. And then at the very end of that, we're going to have a final report, which also has the final response built into it. So it takes the whole entire culmination of that entire workflow inside of XOR, and it puts it into like a nice little formatted email. If you're sending it to this, like the SOC or like some kind of a team that turns over. So, all right. So the first one here is the accuracy concerns. So even like myself, not even kind of creating this demo, just me using ChatGPT in general. If you don't explicitly tell it exactly what you want that outcome to be, it's going to try to guess, and most of the time it's going to be completely wrong, which kind of turns into the hallucinations. And especially in security workflows, that's something that you do not want. You want to have repeatable, expectable responses, especially if you're using this to do some kind of automation. So that kind of leads into this next slide, which is kind of like a guardrail. I call it guardrail. I'm not sure exactly what it's called, but it's pretty much a rule set at the very bottom. So if you see where it says rules, It just kind of gives you an example of what it should do, what it shouldn't do. So you kind of look at this as more of like if or else statement in like a scripting. So it's more a trial and error, because if you actually look at this, if you're trying to use ChatGPT or any kind of AI in this manner, this is just another security tool. So if you stick a security tool right into your environment, what's the first thing that you probably are going to be doing for a little bit? And that's pretty much like tuning and adjusting that to your company's environment. So that's the same principle here. When you try to create a prompt to do these automations, you are going to want to try to have like a bottom rule set that says, hey, if this happens, or don't do this action in this case. It's very trial and error, but I got to a point where it was actually pretty reliable inside the demo that we will be seeing in a little bit. And then this comes into the actual privacy issue. So I think this might be neck and neck with the accuracy problem, because I've heard it in other companies. I go in like Reddit and I look at AI different topics, and number one that keeps coming up is the privacy problem. And what that is so if we're going to be using our data or the company's data to be using ChatGPT, what is that company doing with our data? Is it training their models on it? Is it holding on to it? What if that AI company was breached? All our data is going to be exposed. So there's a couple ways that you can get around this. The first one is you can. I think ChatGPT offers like an enterprise license, and they offer more assurances through that, and they also offer other things. But so the second one is, so I mean, this is actually the third item here, but the second one is actually taking Azure. If you have an Azure environment, ChatGPT offers like some kind of Azure instance you can set up if that's if you want to do that. But then the third one is actually this slide here, which I actually did in the demo, and I actually explained how I did it in the demo. So what it does is, once you get the incident, say it's like an EDR or whatever incident comes into XOR. So what it's going to do is it's going to redact that data. So ChatGPT doesn't care what your internal artifacts are, your IP addresses, your usernames. It doesn't care. So what I did is I redacted it using a Python script. And then the step 2, it's going to send that redacted prompt to ChatGPT. So all the contextual information of the incident still stays intact. So you have like the incident name, the reason why it triggered. You have all the malicious artifacts still in there. That's all it really needs to make an intelligent decision. And then so what happens after that, ChatGPT goes through its workflow, does its thing. And then once you're not going to reach out to that task for ChatGPT anymore, you can then re-inject that data back into either the context key or whichever. And so in this case, in the demo I'm going to show, it's going to inject it back in. So it's going to send all that whole entire story to like the SOC. It's pretty much like an email template. And that's just to demonstrate how it tells it how it's thinking, why it made choices, why it didn't make choices. And in cases where if a playbook fails, it'll actually tell you how to better situate that playbook. So maybe it's like an edge case that the developer didn't think of. And it helps them kind of almost like self-heals the playbook. So that all that data is inside of that final report with the data injected back in it. I'm gonna get a drink of water real quick. All right, so I kind of added this one in here, more of like just give everyone more of like an idea of exactly what the other side's actually doing with AI. So as defenders, we're in like corporations, or we're working for security teams. We're still trying to decide if we're wanting to use this in any capacity in our teams. It's kind of wrapped up in kind of red tape and all that such. While that's happening, the attackers are using this. I've been using it, I think, for quite a while, and they're just getting more and more sophisticated. And uh, so the first one I want to go over is like the AI generated phishing emails. So a lot of like when I first started in cybersecurity, I mean there was no like phish me or Cofense or anything like that. We were literally looking through the headers of the emails, and it was pretty much a shared inbox, exchange inbox, and we just looked through all that. And after a while, it was pretty obvious. You have the usual red flags, kind of a little bit of like a broken English, kind of typos, things that doesn't look right, don't make sense. Well, if they're using this, that all goes away. So, it'll make it a little bit, it make it harder to discern what's actually real, what's not, without really deep diving into it. And then the second one is deepfake technology. So that's actually been happening not just for companies, actually happening for like actual private people, on their own personal devices. There was one story where this lady thought she was having a relationship with I think it was Jason Momoa, and then she was like chatting him on FaceTime or whatever, and actually looked like Jason Momoa, and she was sending him all kinds of money, and I'm not sure why he would need money from her, but it was working. So I mean, it's pretty dangerous, this stuff, and just to take that into more of a corporate kind of spotlight, if like I'm standing up on this thing, this is going to be, probably put on like LinkedIn or whatever. Somebody could actually take my facial structure, see how I'm talking, how my lips are moving, how my voice is sounding, and they can use that to train an actual AI model. So if they could, pretend to be me, FaceTime somebody, FaceTime my boss or whoever, saying, hey, my account got locked out, can you reset my password and whatever. So it's kind of crazy how they're using that technology. And the one that really kind of hits home is the AI-powered malware. So this isn't pretty much in like wide use at the moment. It's pretty much used by like state-sponsored actors. And what this does, it's technically malware with an AI model kind of built into it. So what happens then is if somehow it's like maybe it could be a phishing link, you click on it or whatever you do to it gets on your machine. Technically, that machine is now the malware. So yet you're not looking at it like the malware is affecting the machine. That malware actually owns that machine now. Because what happens is if you block the hash, you block the file name, you try to do anything with your EDR tool, it's going to realize, okay, well, I'm getting blocked here, so what I'm going to do, I'm going to change my hash on the fly. I'm going to change my process name. So it keeps on going through this cycle. And so it's going to keep on doing that. And well, maybe when it changes its hash, it's going to sleep. It's not going to do anything at all. It's to be undetected, for an X amount of time. So that's not the only thing it does do. It also does automated vulnerability scanning. So what this entails is, okay, they're on the machine, they're maybe not detected yet, maybe they were detected, and the analyst or whoever blocked that hash, and like, hey, it's blocked, we deleted it, and it's removed, everything's good, but they didn't realize that it either made a copy of itself or it renamed itself. So while it's kind of hidden, it can actually activate like vulnerability scanning, hitting whatever connections it can to other machines that's connecting to that beachhead. And what happens after that is, let's say that finds a vulnerability in a server. So either it's already preloaded with actual malware, actual packages or exploits or whatnot, or it'll actually reach out to a C2 domain, which they could have hundreds of IP addresses ready to just switch out. And so what happens there is it pulls that, it says, here's a match, we found a vulnerability, and here's the actual package to exploit that, so I'm going to pull it down. So I'm going to pull it down, and I'm going to use it. So the only way, and I was actually thinking about this, like how do you stop this from happening? So the only way to really stop it from happening is like probably right when it gets onto that machine, because the first thing it's probably going to try to do is going to probably try to pivot. It's going to try to copy itself and spread itself to it's almost like a ransomware tactic. So the best thing you do is you have to isolate that machine. You have to isolate it completely in every aspect to make sure that malware doesn't come out. So the main reason, like I said, the main reason why I was kind of going over that is just, again, to show how sophisticated and how dangerous AI is being used in the attacker's sense. All right, so now we're going to go into the demonstration. Maybe edit this. I'm gonna hit run. Oh, actually, it's not on the screen. Hold on a second. It's not on PowerPoint demonstration. Drag it to your other monitor. Oh, okay. Drag it over. Oh, I didn't realize it was screen shared. Okay, let me see. Drag it. Come on. Come on. That's not. Oh, well, let me just.
You may just have to close your PowerPoint.
Yeah, I could try to do that.
Oh, that's definitely it.
Okay, there we go. Yeah. Okay. Can everybody see that okay? Do I need to zoom in or anything good? All right. Sorry about that. So I'm going to go ahead and run it. All right. So with this is the demo. So I'm going to kind of just walk through with exactly what's happening and how ChatGPT is actually interacting with XOR. So the first one you don't really have to worry about. That's just kind of me injecting fake malicious IOCs. All the data in here, it's not any kind of sensitive data or like live data. It's all made up by that task. So the second prompt, or the second task here, I'm gonna zoom in on the, where is it? There we go. I'm not sure if you can see that, but I'll just talk what it's actually showing. So this is a prompt in its entirety that I've been using. It says like you are a tier 1 cybersecurity analyst. You integrated into Palo Alto XOR, and it just goes into the incident content or the context. And the way this is formulated, it's never going to change. This is going to happen through every single incident. It's just so it's formatted correctly to do the actual proper data sanitation. It has extracted indicators, so you can see it has like 192, 168. It has actual potentially real, impacted artifacts that that potentially you don't want being sent out. So the next one it goes to is we're setting the prompt with sensitive data, and then it sanitizes the prompt. Yeah, I'm not sure how good this will show. It's kind of like all jumbled in there, but it's actually replacing it with actually dummy, like was it dummy IP? I'm not sure if you guys probably can't see that, but so it has dummy IP, dummy username. So it's kind of stripping that data out. And then we're going to go down to the sanitized prompts. So this is kind of like the same thing. This is a prompt, so it's taking the data from the above task. It's running a Python script using regular expressions, and that's why it has to stay the same. It pulls that out, puts dummy labels in there, and then it's going to send that completed prompt into ChatGPT. So right here at the top here, it's saying, hey, this is a suspicious credential dumping activity was detected, specifically involving the use tool of Mimikatz. It was listing the host name, which is now dummy host name, dummy IP, and then also lists down here the actual the username. So it also tells you what actions it's taking. Let me see if I can zoom in on this. Zoomed in a little bit. So the actions it's taking, it's saying, okay, we're choosing to quarantine or isolate the machine, and we're presenting in the prompt, we're presenting it, hey, there are these pre-configured actions that you can take if you see that this is actually necessary to take it. So it decided to quarantine the machine, and it decided to block the malicious domain on adding it to the EDL, or the external dynamic list of the firewall, on the block list. And then it also decides to reset the credentials. And potentially this could all be happening in like seconds. So then you have the playbook error handling. So technically there was no errors present, but if there was, it would say, hey, your task failed, and you can actually have the error path, if that task failed, going into ChatGPT to kind of diagnose why that failed. And on top of that, I didn't put it in here, but on top of that, you could actually have it go and find that missing data. Maybe something happened where the context key wasn't populated. You're trying to add a host name to be isolated. It fails because it's null. It's blank. So you can say, hey, the engineer can configure predefined SIM queries. One could be against your EDR. One could be against Windows. So it takes the data it does have. In this case, it would have been like an IP address and maybe a username, whichever, and then it's going to correlate that, and it's going to find that missing data, and it's then it's going to take that, bring that back into the playbook, and then it can go ahead and continue with its incident response. So, and then there's escalation details. So I kind of threw this one in there. There was actually a task in there to notify like the CEO. So I don't think it was logical to notify the CEO at 2 o'clock in the morning over one incident. I kind of just threw that in there just to see what it would do, and probably say 90% of the time it decided not to call the CEO, which is probably good. So then there's recommendations. The recommendations is like implement regular security training and just kind of like basic stuff about Mimikatz. Also, I forgot to mention at the top, where is it? Somewhere in here where it actually assigns, I think it's in here, but it'll actually assign to an APT group. Say, hey, this APT, whatever usually uses this. It'll actually tie it to the MITRE framework, and that's all ChatGPT doing it. So part of one of the prompts I actually put in there was, that I purposely left the MITRE information out, because I wanted to kind of show how it can actually correlate that all on its own. So it pulls in the tactic, the technique, and it correlates that to any kind of APT group. And then in the recommendations, it can also say, hey, these are the usual attack patterns of this APT group, and it might suggest certain tightening or certain additions to your playbook. All right, so let me close that one out. So it sent it to ChatGPT, and then I set a response that the response is just kind of breaking it out into string. And what you see here is XOR is actually taking action on the recommendations by ChatGPT. You have isolate machine, which is tied down into this yellow action. The action is actually not doing anything in the demo, but in the live environment, this would be your automation that is connected to your EDR platform that would actually send out and isolate that machine. And the next one is block XDR. So essentially what that's doing, we're using XDR, so it's going to add the hashes, any kind of file names, paths that it's living on. It's going to automatically block that. And then again, it's adding it to the firewall block list. And this is technically would be happening all at once. I just put these pauses so I could just demonstrate this. And then reset credentials. So we're assuming that the user is not on at 2 o'clock in the morning running Mimikatz on his machine. So we can probably safely deduce that his user account is probably compromised in some way, shape, or form. So it resets his credentials, and I think it also recommends in the final report to reset anyone else's credentials that have used that same machine. So I'm going to go ahead and I'm going to complete these. It takes a little bit, but all right. And then once that's done, it's going to continue down the workflow. So what it's doing now, it's creating an email template, and that email template still has that dummy data in it. So this is kind of demonstrating how we can safely use AI, redacting sensitive information that your company is worried about being exposed. And then once AI is doing what it needs to be doing, it can still safely put that information back into the workflow. I mean, the information never left, to be honest. It's still inside of XOR. we're just kind of replacing the labels so we can send it out to the SOC or whoever, because I don't think it'd do anyone any good if we left that in there trying to let someone know what exactly happened. So let's see, I'll go in here and I think it'll actually show. Yeah, it still has dummy host name in here, still has dummy IP, now it has dummy username. It has all the situation that happened, malicious file observed, suspicious outbound domain. So it's literally giving you a whole entire report of what happened and what it did, and also what it didn't do, and the reason why it didn't do that. So it's completely auditable. You know exactly what it's doing, why it didn't do something. And then also right here, you can see it actually maps the MITRE technique. It's a T1003 credential dumping. So that wasn't in there. I didn't give that to the AI. The AI decided that on its own based on the file and the type of activity that's happening. All right, and then the one underneath it is, so I had to pretty much pull that out from the actual context and create its own context key. And then right here, I ran another Python script where it's pretty much re-injecting that data back in. It says rehydrated report successfully, and then we can actually see the full report. And now if we see the full report here, we can actually see that, if I can click right here. Let me see. Oh, I'll just highlight it. So it's Corp Workstation 1337. That's not a real workstation, but in this sense, in this demonstration, this is a real workstation. And before it was dummy host name. It's no longer dummy host name. It's actually put it back in there, and then also re-injected the IP address, and then also re-injected the username plus the domain, which in this case, it doesn't look like a domain. It's like it's the actual workstation. And then it kind of continues on, and it kind of tells it pretty much what we're seeing in the other one, that it has observed malicious files, what it did. So it's exactly everything that it just sent when it had the dummy data in. You just put that data back in, and now you can go ahead and send that. All right, so that is it for that demonstration. Let me go ahead and try to start this one up again. All right, so okay. So it's a bonus question. So I want for a show of hands, how many people actually use ChatGPT in any sense at all? All right. So how many people actually use it for work? Sending an email, maybe just kind of doing, make sure you're not being offensive to anybody. So anyone that actually works in IT or is in the security department, how many is actually putting incident data in there, or actually saying, hey, I'm creating this regular expression, or I'm trying to create this Python code and I'm having problems. How many actually use it to debug or anything like that? So I'm gonna raise my hand for that one. But yeah, just a disclaimer, any of the incident data you put in there, you want to make sure that it doesn't have any actual data, sensitive data in there. But yeah, so the reason why, and also, so how much did that ChatGPT demo cost me? Anyone have any guesses? Throw some out. The $100. So the probably the entirety of me, not just this demo, but me creating a demo and constantly running it over and over again, probably cost me like 10 cents, if that. This demo right here probably cost me less than 2 cents. Probably cheaper than that. So I'm actually using, in the demo, I'm actually using the GPT-4o model, which isn't the best, but it's the most cost effective. So if you're actually going to be using this in like a live production environment, you'd probably want to use the best of the best at the time, but also that does cost more, but it also increases the logic thinking and the responses and everything that it actually sends you. All right. And that is it. That's anyone have any questions, concerns? Should I stop presenting? I mean, to be honest, like the last time I presented was probably like 5 years ago at RSA, but I've been working from home for quite a while, so I'm trying to get back out there and up my speaking skills and such. So All right. If no one has any questions, then I guess that, yep. Yeah. I'm sorry. What was that? I couldn't hear you. If you want to step up or. Oh, are you talking about like prompt attacks? Um, I don't think so. I didn't get that far into it. But yeah, that's a good question. I'll definitely look into that. So, any other questions for me? Yep. Yeah. Yeah, it actually puts a placeholder, like a label. Let me walk over here. Yeah, it's a label, and so what it does, the script runs, and it says, oh, it's using like regular expression, and it kind of grabs that data and it pulls it out and replaces it with, like, if it's a host name, replaces it with like dummy host name. So it's pretty much, that's decided. That's not like automated in any way. It's all decided like based in the script of what you're actually wanting to redact. And then once it sends it to the ChatGPT or whatever AI, it still has all the context of everything else in there, just what you changed. And then it responds still with like dummy data. Then once you're done using ChatGPT, you want to do like a summary report or whatever. Then it pretty much takes the script, puts it back in. It's a different script, but it's really just grabbing the same context key. So the keys never are deleted, never changed at all inside of the SOAR platform. So yeah, it's just kind of just removing it from the equation for a minute. So ChatGPT does its thing, and then once it's done, it just puts it right back in. So, all right. Any other questions? Yep. Right here. Somebody. Yep. Yep. No, no. I mean, I'm with ADT, and they're still kind of trying to figure out where their place is in this, not just this, but just AI in general. But hopefully, after watching my presentation, because I'm pretty sure they're going to, maybe they'll change their mind. But again, like the main concern, not just from my company, but other companies I've heard, was the data privacy problem. But hopefully with what I demonstrated here, I'm sure there's other more straightforward, cleaner ways to do it. But that's one way that you can resolve that problem. So, yep.
Yeah, I apologize, I missed the earlier part.
Yep.
Yeah, what was the workflow software you were using that makes some calls on?
Oh, that was XOR. Yeah, Palo Alto's. What used to be Demisto, but now it's their SOAR product. So I mean, a lot of the stuff you can use inside the playbook, like I said, but there's certain portions, like it depends. It all depends on how you create the playbook. If you're going to create the playbook to where it follows like a static workflow, like say, I mean, I don't recommend this workflow, but let's say you're basing it all based on IOC reputations. So in this case, if you did that, you would have an alert that triggered using Mimikatz at 2 o'clock in the morning. But then the IOCs came back all benign or unknown. I mean, it could say, okay, well, they could do an equation and say, okay, well, this isn't a critical threat, or this isn't something to be concerned about, and it would drop it. It could close it, and then that kind of goes unknown, and then the attacker's going, doing what it wants to do. But with AI, it looks at the whole entire picture, the behavior and everything. Like, could you code that into XOR by itself? You probably could, but if there's edge cases or if there's some situations you weren't expecting, the task or the playbook's going to fail. It's not going to read something correctly. So this kind of just over encompasses everything. It adds like real thinking logic outside of XOR. So, all right. Any other questions for me? So, all right. And that, I'll wrap it up. Thank you.